Welcome to Algebra 1 5.1.3 Vertex Form for Quadratics. An equation is in vertex form for a quadratic function when it is written in this way. F of x equals a times x minus h squared plus k. The a, the h, and the k are real numbers. We usually use integers, but not always. Sometimes they're decimals and fractions. But a cannot equal 0. If a is equal to 0, then it is not a quadratic function. The first question is, what is the vertex for the graph of the quadratic function? The second question is, what other key characteristics about the graph are revealed in this equation? And the third question is, what are similarities between the vertex form, which is the form you're seeing today, the factored form, which was in our last lesson, that's g of x equals a times x minus r 1 and then times x minus r 2, and standard form, which was h of x equals ax squared plus bx plus c. All right, well, the answers to these questions, let's start with the first one. The vertex of the quadratic function is hk. That's because x minus h means the graph is moving right h if h is positive and left h if h is negative. So it's a horizontal translation. And then plus k is telling you to move the graph up if k is positive and down if k is negative. So the vertex is the hk. It was right h up k, or left and down if they're negative. All right, what other key characteristics about the graph are revealed in an equation of this form? Well, if a is positive, that's telling you the parabola for this graph will open up. We say concave up when a graph opens up. If a is negative, the graph opens down. We say concave down when a parabola opens down. And if the value for a is greater than 1 or less than negative 1, like a 2, 3, or 4, or a negative 2, negative 3, and so on, then the graph is stretched vertically by a factor of a. So you may have a tall, skinny parabola, or it can open up or open down, of course. If the value of a is between positive 1 and negative 1, so it's a half or negative 1/3 or something like that, the graph is compressed vertically by a factor of a. So think of it as this is like half as tall when you have an a that's a 1/2, or 1/3 is tall. It's like shorter. It's squished vertically. All right, and then the last question is, what are similarities between these three forms? Well, each one you'll notice has an a in the front, and that's exactly the same number. So whatever form you're writing your equations in, that number in front will stay the same from one form to the other. So that's nice to know. And then the other thing is they must all have an exponent of 2 in them somewhere. So you'll notice that in the vertex form you see the exponent of 2, and in the factored form you see an exponent of 2, and you may think, well, the factored form doesn't have an exponent of 2, and I guess you're technically right, it doesn't show the exponent 2, but x times x will give you x squared, and since you have this binomial x minus r1 and the other binomial x minus r2, if you were to multiply those binomials, and we'll be doing some of that actually pretty soon, you'll see that you will always get an x squared there as well. So that's not quite 100% true. They all have exponents of 2, but they really do. They're all degree 2, we say. All right, so the next question that you're given is you have 5 students, and they have written an equation, or tried to write an equation for a quadratic function in vertex form so that the graph opens up or is concave up, and the vertex of the graph is -6, -4. So you'll notice the thumbs up and the thumbs down. The ones that are thumbs up are correct, and then the ones that were thumbs down are incorrect. So the question is, what do the correct answers all have in common? So let's look at these. Simone and Teresa and Erica all have x plus 6, and they all have -4, -4, -4. They all have a positive a value, the 3, the 1/4, and then Erica doesn't even have a number in front, so it's like an a value of 1. So each one of theirs have those things in common. They all have the x plus 6 squared, the negative 4 at the end, and the a values are positive. What are different? Well, each of their names are different. So Simone has an S, Teresa has an F or T, I'm not sure what that is, and Erica has a D, so those are different. They have different values for A, 3, 1/4, and 1. And then C, what should Jesse and Leon change to correct their answers? Well, Jesse does have the x plus 6 and the minus 4, and that part's good. But his negative 3 needs to be positive so that his graph will open up, because the A value needs to be positive for it to open up. And then Leon, if you'll notice, he has a minus 6 in the parentheses. And so Simone, Teresa, and Erica had the plus 6 in the parentheses. So Leon should have a positive 6 there. All right, so let's go on to the next page. We're going to use technology to do some graphing, and I've given you a link out to the Desmos calculator to do this. So for number 5, just click on the link to open up your Desmos calculator, like so. And when you get in here, it's just going to be a blank graph with an ordinary grid. I like to change this so that there's no minor grid lines. And I do want to be able to see all of the grid lines from -10 to 10 or something similar to this. So if you click on the wrench, you can adjust your graph. Now in this first equation, I'm going to show you something cool here. You can actually cut and paste this. If you're on like a desktop or a computer or anything, even a Chromebook, I believe, you can highlight that and copy it and then paste it. Now it won't take this exponent, unfortunately, but if you'll do Shift-6, you can turn that into a square, and then you'll see your parabola. Well, if we're going to write an equation for h of x in factored form, what we really need to know are our zeros. So those are your x-intercepts. So if you'll highlight those, then you can create an equation. I'm just going to do that again. That was 2 and that was 6. So what I need to do is use a factor of x minus 2 and another factor of x minus 6 to have those, to get those zeros in the graph. So over here, let's type h of x equals x minus 2, and then the other one was x minus 6. Whoops, not 5, 6. Now if you do it correctly, it'll actually go straight on top of the other graph so that you'll know you've done it correctly. If it's not right on top of the other graph, then it's wrong. So this is called factored form. You'll notice the x squared did not have a number in front, so we have no number in front here either, and that's good to remember. Now let's click on 3 and let's try vertex form. Well, if the vertex form is going to have the vertex in it, so this has a 4, -4. So if I want to move right 4, I'm going to put x minus 4 in my parentheses. And to move down 4, we're going to put the -4 at the end. So it should look something like this. H of x equals, then we'll put x minus 4 and then square that. And then I need to move it down, so we'll do right arrow to get off that exponent, and then -4. All right, so this is the exact same parabola, and there's your -4. Now, one way to copy this is to share out. Up here at the top, there's a little share. Let's see if I can pull this down. If you click on this, it's going to let you share your graph. So for those of you who have the ability to do this, if you're on any kind of device like a desktop, a laptop, a Chromebook, I know you can on those. I'm not sure about tablets and phones. If you can't do it, you can't do it. But if you can do it, that would be awesome to see your graphs. I'd love to see them. But there's so many options in here. I don't like the small square. The large square gives me way more detail. So those are cool. On the desktop computers, though, you can really do a lot. Because let me show you what I'm going to do. I'm going to click on these points, and I'm going to highlight them. Oops. And then I'm going to actually use my snipping tool Oops, it didn't like that. I'm going to do a new snip here. Let's do this. I'm going to snip all this. And then I'm just going to paste it. It's so much easier. Alright, so I'm going to paste that. So if I go back to my document, I can just drop it in there. So let's go back to this and I'll just drop it in. And there it is. Alright, so I have all my beautiful little graph there. Don't feel like you need to make anything pretty, and you definitely don't need this much. If you just put the two equations, h of x equals x minus 2 times x minus 6, and h of x equals x minus 4 squared minus 4, that is plenty sufficient. But if you're able to put the graph in there with it, that would be awesome. And that way you can kind of see it all put together. It helps you to actually learn this if you have all these in the same place. All right, I'm going to go to the next one. Now this time we do have a value in front of our x squared term other than 1. So this a value is negative 2. So that's going to make a big change in our graph. So I'm going to go here and highlight this. Of course, you can just type these in manually. If you can't highlight and cut and paste, cutting and pasting is always good. I'm going to paste it right here. And notice it won't take that 2 exponent, but if you'll just highlight it and hit Shift 6, it'll convert that for you. Now this one, I need to get rid of these. Okay, now my window's not so great because I can't really see high. So I'm going to hit the wrench here and change my Y so that it goes up to like 35 or 40. I think is good. And maybe negative 10. And I don't want to count by 1s. Let's count by 5s. Let's see what that looks like. That's okay. My x's should be counting by 1, so let's see if I can change that. Negative 5 to 5, or maybe to 10. That's better. Alright, if you click on projector mode, it'll make everything bolder, so that's kind of nice. Alright, I'm going to drag this around till I get a good looking grid. I don't have my labels on, which is kind of annoying. Let me see if I can put those on. To put your label on, just put an X here. You can put a Y here. So I'm going to turn those on. Alright, so this looks pretty good. Now what I need are my zeros. So I'm going to highlight this x-intercept and this x-intercept. So negative 2 is one x-intercept and positive 5 is the other. So that'll help me create my factored form for this one. So let's go to the second row and let's put r of x equals, I'm going to put the negative 2, that's that a value, you need it, and then I need the x plus 2 for my negative 2 x-intercept, and I need an x minus 5 for my other x-intercept. So let's check that again. There's your x-intercept, there's your x-intercept, and this is the equation. Y'all can't see that too good, so let me stretch it out a little bit. Okay. Anyway, it's so big it doesn't even show the end of that, but oh well. Just back up here. Alright, so can I move this? Yeah, it's gonna let me do it. Alright, so let's do this. I'm just gonna pull this over. There we go. And then I'll do this. Okay, that looks good enough. Alright, so now what do I need? I need vertex form. So let's go up here to the top. You just really have to get a little bit close to it and it'll show it. It's that point. Notice it highlights all these important points, including the y-intercept. And that y-intercept is that 20 that was in the original equation. So this vertex up here, I'm going to use that to write my equation, and that's a weird answer. That's decimals, so we got to remember that I would get 1.5. So I'm going to go right 1.5 and up 24.5. So let's try to remember that. All right, so the next one we're going to do the r of x again, same name, do the equal sign, do the -2, and then we'll do x minus 1.5, and then that quantity is squared, so you go shift 6 and put your 2. And then you got to go right to get off that exponent, and then we're going to go up. Let's see if I can remember this. 24.5? Oh, yeah. Okay. So that's the point. And again, I'm not able to see that too good, so let's see if I can stretch it out a hair. Yeah, I can do it. All right, that's good enough. Now what I'm going to do is go ahead and highlight these points. That point, this point. Oh, y'all aren't seeing that one, my bad. Let me zoom in small so I can get that to show. All right, there we go. So we're going to highlight these. I'm going to highlight that one too. All right, that's a good looking graph, and I've got all my equations. The 24.5 is almost covered up here, but let me just copy this. Just copy all of this and drop it into my document. Oops. All right. So now y'all get to see how I make all y'all stuff. This is exactly what I do. Alright, so we're going to go Control V, and there you have it. I've got all this wonderful stuff right there in your document. Just drop it in. So everything's showing. You can see the x-intercepts, and now you can see where that x plus 2 and x minus 5 came from. And then you can see your vertex, so you can kind of tell where these two numbers came from. And then you can see the 20, which is the 20, the y-intercept on that graph. Alright, so you probably should pause the graph at this point. I mean, pause the video at this point and try a couple yourself. I'm not going to stop, so you're going to have to pause me. But let's go ahead and type in this one. So I'm going to do Control C to copy, and then I go to Desmos, and I'm going to, let's get rid of this. Oh, I don't need that. What am I doing? Alright, and then I want to do, and get in here. Alright, I'm going to get rid of this one and Control V. Now this exponent's not right, so let's do Shift 6 and fix it. We'll get rid of this, we'll get rid of this. And then I'm going to go back to my window and do Zoom Square and change everything back, because I really don't want to count by. There we go. Nice Zoom Square. Oops, if you zoom in at all though, I mean zoom out too much, it'll get rid of your minor grid lines. You can't see what you're doing. So I zoomed back in. That looks pretty good. Alright, so this time my x-intercepts are 0 and -4. So for w of x, name of the function, equals, the number in front is actually -1, so you do need your negative. If your x-intercept is -4, you're going to need x plus 4. And if your other x-intercept is 0, you're going to need x, but you don't really need parentheses, and you don't really need to put minus or plus anything. If you want to use parentheses, it won't matter. You can, in fact, I want you to play with this, so please do. Feel free to change it up and see how many different ways you can write these, but this is sufficient for your factored form. You may want to put your x first and then put your x plus 4. So you could have a negative x and then x plus 4. So let me show you that. So I'll put it here. Same thing. You could do x plus 0, x minus 0. That works okay. I'm just going to leave that for this one. Alright, let's go to the next one. This one's w of x. Oops. Equals. Now we need the vertex form. Alright, well let's click on the vertex and see what that is. Alright, it says -2, 4. So if I'm going to go left 2, I'll need an x plus 2 inside the parentheses. And then 4 means up 4, so I'll need a plus 4 at the end. So let's see, we'll start with the negative in front because they all have that. And so we're going to do x plus 2 We'll square that. And then we need a, let's see, plus 4. There it is. It's the same problem. So to fix that, let's highlight these. I'm going to click on them. And I'm going to just cut all this and put it in the key. Later on, I'll probably give you all this key so that you can use it as a study guide. But for now, I'm just going to give it to the teacher so they can kind of see what's going on. All right, so I keep pressing the wrong thing, don't I? All right, there we go. You see the x-intercepts. It just so happens the y-intercept is 0, so that's why that first equation didn't really have anything at the end. Now this last one's a little different. You got 3x squared minus 3. So I'm going to highlight that. I'm going to put that in here. And of course we got to fix that exponent every time because it won't keep it. Alright, so that'll be shift 6 to make that an exponent. We'll get rid of these two. X those out. Looks pretty good. I don't think I'm going to change a thing. I'm going to leave it just like that. Alright, so this time you'll notice the graph is skinny and steep. That's because of that 3 in the front, so it's really a lot skinnier than the other parabolas that we've seen. To do factored form, my x-intercepts are -1 and +1. So I'm going to need to keep that 3 that's in front. So go ahead and put your 3. And then your factors will be x plus 1 and x minus 1. Either order actually works. And so that looks pretty good. Alright, so let me stretch this out just a hair. Alright, so let's go down to the last equation here. We're going to go ahead and highlight this vertex. And you'll notice something. The x is 0 and the y is -3. Well, if I just retype the first equation, that equation is technically in vertex form because you're not adding anything to this x. I'll show you what I mean. I can do this. This is totally not necessary, by the way, but I'm just going to show you. You can do x minus 0 squared, so shift 6 and put your exponent of 2. Whoops, not percent. My bad. I'm just picking the wrong button here. Shift 6, put your 2, and then put your -3. So you'll notice that function is the same. You don't really need to put x minus 0. My point is you could just take that off and put x squared there, and it's the same thing. So really, the function was in vertex form. The function was in both standard form and vertex form, and the reason this is vertex form and standard form is because it doesn't have the x term. There is no x term, so there is no difference between vertex form and standard form. So let's go ahead and highlight this, and I'll highlight that one too, and then I'm going to copy this, and I'm going to paste it into my document. Let's do that again. I don't want that thing at the bottom. Okay. Good enough. Alright, so we're going to copy it and we're going to paste that into our document. Okay. Alright, the next page, you're not really doing Desmos. In fact, you really shouldn't unless you have to. Your goal here is to answer these questions from what you've learned. So let's see what we've learned. It says identify the form of each quadratic function as either standard form, factored form, or vertex form. And then state all that you know about that quadratic function's key characteristics based only on the equation. In other words, don't graph it and see what's up. See if you can determine what's going on without looking at the graph in the calculator. Of course, if you need the calculator, if you're taking a quiz or a test, absolutely, positively, you should type this and look at it to get some help. But our goal is to remember some things without having to type it in, just to save on time. So this first one has the negative in front. So what is that telling us? Well, this opens down because of A. Well, wait a minute, we forgot the most important part. This particular function is written in vertex form. And that's because you have the parentheses with the exponent 2, and you have the plus 9 outside, so this is your vertex form. It is not in factored form because you can't really see the exponent 2 in factored form, at least not usually, and it's not in standard form because there will be no binomials squared in standard form. All right, it opens down, so that is true. Let's see, the minus 1 and the plus 9 are telling us that the vertex is 1, 9, because it goes right 1 up 9. And let's see, that's probably it. I do know all of these are parabolas, so we could say that. And we could probably say other things, like the axis of symmetry is x equals 1, but those are the main things. So we're just going to stick with the main things. A vertex form, it opens down, and the vertex is 1, 9. All right, so the next one, let's see. This time we do not have the binomial squared. We just have an x squared. So this one would be in standard form. It doesn't have a value for c showing. That means the c value is 0. So what can you see in standard form? Well, just like before, I can tell that it opens up. I do know this one is stretched vertically by a factor of 2. Oh, I left a letter out. Let's fix that. Because of the 2 in the front, it's going to be stretched. So it's going to be a tall, skinny parabola. So let's hit enter and see what else can we say. Opens up, vertically stretched. Oh yeah, I can tell the y-intercept is 0 because there's no number added to the end. So that must mean the y-intercept is 0. Okay, C. Well, these are kind of the obvious ones. When you see these parentheses like this, these are your factors, and those reveal your zeros or your x-intercepts. So this is factored form when you see these factors. So let's put factored form. All right, the negative 1/2 in the front means it's opening down. It's also half as steep, or you could say it's compressed vertically by a factor of 1/2, so it's something like that is fine. The minus x minus 3 reveals the x-intercept 3, and the x plus 2 reveals the other x-intercept negative 2. So I can tell the x-intercepts are 3 and negative 2. Notice the sign change. They're not the same signs you're seeing in the equation. They're different. Is there anything else I can see just from looking at this? Well, no. I could multiply it out and I'd see something else, but I'm not going to do that because I want to just see it in this form. So that's about it. Opens down, half as steep, and the x-intercepts. Now, what about this one? Well, this one is actually in both standard form. It doesn't have the factors showing, but it's also in vertex form. And that's because there's no x term. So your vertex would be 0, negative 5, because it's not being translated left or right. There's nothing added to the x before it's squared. So that's your vertex, which is also your y-intercept. Your y-intercept is negative 5. And you can put 0, negative 5, or just negative 5. That's both are correct. I can tell this one opens up because there's no negative in the front of the x squared. And got the vertex, the y-intercept. I can tell it opens up. It's not stretched or compressed. It's just got a coefficient of 1 in front of x squared. So I guess that's about it for that one. All right, so you're finished with this lesson, at least this part of the lesson. So to see if you've learned what you need to, complete your exit ticket, which is a Google form, and submit that, and then submit this assignment. As far as what you type in this document, I would encourage you to type all that you can possibly type. If you're on a phone or some device where that's really challenging for you, just do the best that you can, but make an attempt, please. Try to make an attempt to put some things in this document. Your grade is primarily your exit ticket, but I just want to give you an opportunity to play with the tools that are in Google Classroom or in Google Docs and in Desmos. It's really kind of fun, and I hope to use Desmos more even after we return back to the campus. If you have any questions, please leave a comment. You can email me or leave a comment on the assignment, and I will get back to you as soon as possible. Stay safe, and I will see y'all again for the next lesson.